it. Sometimes y'all know I don't do very good at that. Start with the more complicated and transform it step by step until it's identical to the other side. Number 2, it is sometimes helpful to verify an identity by rewriting one of the sides in terms of sines and cosines. Number 3, determine whether the following statement is true. To verify the identity below, begin by multiplying both sides by sine times 1 plus cosine x, or the least common denominator. When you do that, this side, the 1 plus cosine x will cancel. This side, the sine will cancel. So you get sine squared x equals 1 minus cosine x times 1 plus cosine x. You do FOIL, you get sine squared equals 1 minus cosine squared. They're trying to see if it's equal to that. Well, let's see. False. Choose the option that's correct. And let me look here. I'm pretty sure that's, what number are we on? 3? The question here was not whether this is equal to this, because it is, but it is this the process? And they're wanting you to say, no, that's not the process. What you're supposed to do is choose one side and multiply the numerator and the denominator by the same factor. So this is a question about process. Number 4 in section 1 says fill in the blank so that the resulting statement is true. 1 minus cosecant x minus 1 over cosecant x plus 1 can be simplified using, if you multiply both sides of that, if you get a common denominator, that's what they're wanting you to do, is get a common denominator. So they're wanting you to multiply both fractions by cosecant x minus 1 and cosecant x plus 1. So that's the answer to that part. Number 5, you can use your graphing calculator to provide evidence of an identity. Graph the left side and the right side separately and see if the two graphs are identical. I feel like those you probably got, because honestly, if they're multiple choice, if you guess 5 times, you should get it right. Honestly, you should get it right on the 4th guess, right? I mean, if you keep guessing, eventually you figure out that one's wrong and you try something else. So the next one says, verify this identity. Cosine x times tangent x equals sine x. So here we go. I rewrote tangent as sine over cosine. And then the cosines will cancel, and all I'm left with is sine. Here's the answer. Express in terms of sines and cosines. That's the first thing we did. We didn't factor anything out. We didn't separate the quotient. We didn't apply an even and odd identity. Then we call it canceling. They're calling it divide out the common factor. So that's the answer choice you use. When we say cancel, they mean divide out the common factor. Okay, that's number 6. Number 7. To verify the identity, start with the more complicated side and transform it to look like the other side. Choose the correct transformations and transform the expression on each step. So the cotangent of negative x times the sine of x. Well, they want you to be dealing in x. So they want to go over here to cotangent of negative x is equal to the negative cotangent of x. They want you to use that part first. So we write it as negative cotangent x times the sine of x. What did we do? Well, let's go back and see. We used an even and odd identity. Let's see if one of the things says that. Yes, it does, right here. It says apply the appropriate even odd identity. Okay, so that's number 1. Number 2, we rewrite cotangent as cosine over sine. That comes from the right here, quotient identities. So the next thing we did, express in terms of sines and cosines. It doesn't say anything about a quotient identity, but that's what we did. Next step, the sign's going to cancel, and that's called dividing out the common factor. So that's number 7. Is this helpful? Are these the ones that were easy? You want to keep going just like this? Y'all, okay. 8, verify the identity. Cosine times cosecant times tangent is equal to 1. So what they're going to do is they're going to write everything in terms of sine and cosine. Cosine stays the same. Cosecant's really 1 over sine. And tangent sine over cosine. And when you do that, that cosine cancels with that cosine, and that sine cancels with that sine, and all you're left with is 1. Number 9, verify the identity. Secant x minus secant x times sine squared x equals cosine. Okay, they have a common item, so we're going to factor it out, just like if we had 2x plus 6, and we factored out a 2. We're going to do the same thing over here. We're going to factor out a secant. When we do, we're left with 1 minus sine squared. Okay, so what did we do down here? We factored out the greatest common factor, which was secant x. Next step. 1 minus sine squared. If I rearrange this identity, this Pythagorean identity, if I subtract sine from both sides, cosine squared will equal 1 minus sine squared. So 1 minus sine squared gets replaced with cosine squared. And what did I do there? I applied one of those Pythagorean identities. So here I am at secant times cosine squared. Well, I'm going to change secant into sine or cosine, whichever one it changes into. There it is right there. Secant is really 1 over the cosine. So I'm going to write this. I'm going to go here and write it to the side. 1 over cosine times cosine squared x. And then if I multiply them together, this is what it looks like. Now, what did I do on 3? I applied a reciprocal identity to rewrite secant. Now I'm going to cancel 1 cosine with one of those, and I'm just left with cosine x, and that's called dividing out the common factor. That was number 9. Number 10, verify the identity. Tangent squared plus secant squared equals 1 plus 2 tangent squared. So, which of the following 4 statements establishes the identity? Tangent squared plus secant squared equals tangent squared x plus 1 plus tangent squared x equals 1 plus 2 tangent squared x. Now, they're saying that secant is equal to 1 plus tangent. I don't know. Let me go over here and see. Yep, right there. Secant equals 1 plus tangent. So they took secant out and replaced it with this. And that way, they had tangent plus 1 plus tangent. So they had 2 of those tangents. That's how that 2 got there. Okay? This is different than anything you've ever done in your whole entire life. And until you see it done, you're just standing there going, I have no idea where to start. I know how that feels, but just hang in there. This video should be very helpful because we're going right over all the homework problems, right? Okay, verify the identity. Cosecant minus sine equals cotangent times cosine. To verify the identity, start with the complicated side and transform it. So cosecant minus sine equals, we're going to rewrite cosecant as 1 over sine minus sine. So what did I use? A reciprocal identity. Then I've got to get a common denominator. I'm going to write it over here. The first step said 1 over sine theta minus sine theta. Well, that's really over 1. And I got to get a common denominator of sine. The first fraction doesn't have to change. The second fraction, I'm going to multiply. It's going to be sine squared. So when I put all this together, I get this 1 minus sine squared over sine. And what did I do? I combined using the least common denominator. Number 3 says replace 1 minus sine squared with cosine squared. That's a Pythagorean identity. When you do that, you can break this apart as cosine over sine times 1 over sine. Cosine over sine is the cotangent, not 1 over sine, times the cosine, times the cosine. What did we do? We rewrote it as a product of trig functions and quotient identity. Okay, so that's 11. How are y'all doing? Helpful? You bored? No? Yeah? Well, yeah, kind of, but I got to do it anyway, so we're going to tough it out. Okay. Stop me if you have a specific question or if I'm going too fast or too slow or whatever. I'm going to keep going until you stop me, but you're not going to hurt my feelings if you stop and ask me something. Verify the identity.
Okay, I have a question.
Okay.
Okay. I know what to do until after you apply the first reciprocal identity, like on number 11.
Mm-hmm.
And then after that, I'm lost.
Okay. So you have no trouble at all turning stuff into sine and cosine.
Right.
Okay. Well, you just have to look at it and you have to kind of, I'll tell you what, looking at these little things down here give you some idea. But the more of these you do, the better you get. It's kind of like when you learn to factor. Do you remember learning to factor from 3 things into 2 binomials and how frustrating it was? This is kind of the same feeling. But I will tell you this hint. I had a fraction, and then I had something that was a different term that was not a fraction. And the ultimate goal in this problem was 2 things multiplied together. Like the end product doesn't have a minus sign. So that's a hint that I need to put these 2 items together, okay? If I put them together, then maybe I'll end up with something that's being multiplied because they definitely don't want a minus sign in the answer. So there's a hint there. How do we know that that's what we're supposed to do? Well, you had 2 terms and they wanted it to be a product instead of a difference. So I'll try to remember it and tell you that as we work through these. Cosine squared times 1 plus tangent squared equals 1. And we're trying to get it to equal 1. So let's see, what do they want us to do here? Verify the identity, start with the more complicated side and transform it to look like the other side. Okay, I have a question for you. Do y'all look at that and want to distribute? Is that what y'all want to do? Do you feel like you should distribute? Let's see what happens if you do. If you distribute the cosine, you're going to get, I'll put that in this little box because I don't know if it's going to work or not, cosine squared theta plus cosine squared theta times the tangent of theta squared. Okay, so this is cosine squared theta plus, well, tangent squared is really what? Sine over cosine. So I get it written like that, those will mark out, and I'm left with cosine squared theta plus sine squared theta, and that's really equal to 1. Okay? And what did I do first? I distributed. But let's look at these answer choices. Distribute's not one of those things that I can do. I didn't get it wrong when I distributed, but they're trying to guide you through the path that's the easiest. It might not be the first one you think of, but it's a path that's going to get you there in less work. So look at these 4 choices and think, well, what can I do? 1 plus tan squared. Go over here and look. I would keep this sheet right there with me, and I would go back and forth. And if it says apply Pythagorean identity, I'd look and I'd say, well, does one of these help me? And it does, because 1 plus tan squared is equal to secant squared. So that's what they did first, was they applied a Pythagorean identity. They swapped it out. Then they had cosine times secant squared. And then what do we do? Well, what are the choices? Reciprocal identity, appropriate even and odd. Well, doesn't have anything to do with even and odd. Quotient identity, Pythagorean identity. Well, let me go see. What do we have here? Cosine and secant. The secant is 1 over the cosine. It's a reciprocal identity. Pythagorean identity. Is there anything in there that'll help me? No, I just used it. If I use the other one, I'm going to go backwards. I don't want to do that. What's the other option? Quotient identity. No, because I don't have a tangent or a cotangent, so I'm not going to use a quotient identity. So I'm going to use this reciprocal identity, and I'm going to change secant into 1 over cosine. Just it's going to be squared. It works whether it's to the first degree or second degree. When I do that, I think at that point y'all probably see what that probably jumps out at you. You feel pretty comfortable picking that out. And instead of calling it cancel, it's called divide out the common factor. Okay, did that help a little bit on how to maneuver through these answer choices and your identity sheet? 13. Questions? Y'all need to stop me and ask anything? Number 13. Verify the identity. Tangent of t times the secant of t equals the secant squared minus 1 over the sine. Okay, where do I start? Where do I start? Which of the following 3 statements establishes this identity? So let's see. They've worked it out for you. They just want you to say it's right or it's wrong. The first one, they have the tangent times the secant. That's the original statement right there. Equals the tangent. Is secant really sine over tangent? No. Secant is equal to 1 over cosine. Sine over tangent is really sine times cosine over sine. So that would just be cosine, not 1 over cosine. So that's not right. That's in the wrong order. Then they're asking you if secant can be replaced with cotangent over cosecant. Is the secant equal to the cotangent times 1 over the cosecant? Well, let's see. What's the cotangent? It's cosine over sine. What's the cosecant? It's 1 over sine. But they've got it flipped. It's sine over 1. Again, that turns out to be cosine. No, that's not what secant is. It's not cosine. It's 1 over the cosine. So when we get to this one and it says tangent times sine, that's tangent times 1 over cosine. I don't know where that came from. Tangent is sine over cosine times 1 over the sine. That's going to cancel out and give me that 1 over cosine. So it's this one that does the proper step. That one's kind of hard. Then once you do that, you're going to get tangent squared over the sine. And you go over here to your sheet, tangent squared at the top is equal to secant squared minus 1. If you move the 1 over, it'd be minus 1. Okay? Number 14. Sine squared over tangent equals sine times cosine. So which one's correct? Sine squared over tangent squared equals sine times cosine over sine. Now here's how they stretch that out. Sine squared is sine times sine. I think y'all believe that. That's just plain old exponent work. The tangent being on the bottom, it means it's the cotangent. It's the flip of the tangent. So the tangent sine over cosine, so when you flip it, it'd be cosine over sine, which is what they have here. And then those would cancel, and you'd get sine t, cosine t. The first one's wrong because they put sine times cosine when they should have had sine and sine. The second one's wrong because they put the tangent here, and with the tangent being on the bottom, this one should have been flipped. And the fourth one's wrong because they made two errors. That's wrong and that's wrong. Okay, questions so far? Let's look at 15. Cosine squared over sine equals cosecant minus sine. To verify the identity, start with the more complicated side and transform to look like the other side. So we're going to replace cosine squared. We're going to go over here and we'll say, there's cosine squared right there. It would be equal to 1 minus sine squared if I move that sine squared over. So that's what we did. We replace it with 1 minus sine squared. We applied a Pythagorean identity. Then, here's what your problem looks like. 1 minus sine squared t over sine t. And the answer is something being subtracted. So I don't want to get rid of the subtraction. In fact, I want to split this into two things. So think back, if you will, to how you add and subtract fractions. They have to have a common denominator, and you add and subtract the numerators. So this is really 1 over sine minus sine squared over sine. So you split them apart. That's a trick you can use. Probably never needed to do that before in your life, but you do it here. 1 over sine, and then when you get this one split, it'll cancel, and you're left with sine. So you got 1 over sine t, which is the cosecant of t, minus the sine of t. Now let's go through the steps. I did the Pythagorean, and then number 2, I separated the quotient into two terms. I split that fraction, okay? Number 3, divide out the common factor. That's where I canceled. And number 4, I went from writing 1 over sine to writing cosecant. So that's reciprocal identity. Okay? That's 15. 16, verify the identity. To verify the identity, start with the more complicated side and transform it to the other side. So you've got 1 plus sine theta over cosine theta. We split it. The first thing we did was we separated it into two terms because it went from being one fraction to being two items. So you're looking at that going, I've got to get that split into two items. So when I do that, I get 1 over cosine plus sine over cosine. Then go to your chart. 1 over cosine is really the secant. That's a reciprocal identity. And sine over cosine is a quotient identity. So somewhere it's going to say use both of them. Right there. We applied a reciprocal and a quotient identity. Okay? Somebody came in my room. I got to answer a quick question. So y'all think about if you have any questions for me.
So on 12, would that just be 9? Because
No, you can't add those together because this doesn't have a square on it. You can't add the 4 with it because 4 doesn't have an x at all. You can't add the 5x to anything because it doesn't have a square.
So I just say like that?
Well, you put it in order from the highest exponent to the lowest exponent. Okay? All right. So, y'all think up any questions? Anything? Y'all just want me to keep going? Okay.
I have a question on section 2.
Okay.
Can you do number 15?
Yes, I can. Find the exact value of the following expression. Tangent of 5 pi over 6 plus 5 pi over 4. Is that what your problem says?
Let me pull it up.
If not, it's very similar. It might not be the exact thing. But okay. So we're at 5 pi over 6. We're right here. So you need this chart this time. Now the tangent. Let's talk about what the tangent is. Every time you have one of these, they give you x and they give you y. And oh, hello. They're from Bradley, and this is my online class. Now I have adults in the room, so kids don't. But when the adult hears me, they get a little tickled. Okay. I don't know how long I've been going, but we started at 12:45. So come 15 minutes, 15. Okay. X and Y. So when we make our ratio for tangent is y over x. So it's going to be this over this. And basically, the denominators are going to cancel. So the tangent of 5 pi over 6 is going to be 1 over the square root of -3. Now, we don't like square roots in the bottom. We'll deal with that in a second. Let me pull the other value from the chart. 5 pi over 4 is here. And we want its tangent. So we want its y value over its x value. Well, they're the same thing. So when you put that one over that one, you're going to get 1. Okay? Now, I'm going to go ahead and fix this one. It's going to be negative square root of 3 over 3 plus 1. I multiplied. Let me work it out so that I make sure I don't do anything wrong in my head. Multiply by the square root of 3 over the square root of 3, and I get square root of 3 over negative square root of 9, which is -3. So there's my problem. I need to put it together. I'm going to change that so that it has a denominator of 3. I don't have a whole lot of room. I'm just going to make it look like that. So basically, this is -3 plus 3, which is written this way, over 3. That nothing cancels because this 3 is underneath the radical right here. Type an exact answer using radicals as needed. Rationalize the denominator. Okay? So we got 10 minutes to go. So does that help on 15?
Yes, ma'am.
Okay. What else? Other specific questions from this chapter? Anybody? Some of y'all look frozen. Are y'all frozen? Okay. Can y'all hear me? Okay, I can hear something now. I don't know who, but I can hear somebody.
Can you work?
You might need to type it to me in a message because I don't think I can. I'm not hearing you. Okay, I think Macy was trying to ask me something, but I didn't hear her, so. Can you work problems from section 5? Sure. Somewhere I have section 5. Okay. Fill in each blank so that the resulting statement is true. The solutions of sine x equals square root of 2 over 2 from 0 to 2 pi are x equals pi over 4 and. Okay. This is the sine. Sine deals with y in the xy location. Don't let the x is like theta right there. So where is it the square root of 2 over 2? Well, let's look at our circle chart. There's one place where the y value is square root of 2 over 2. It's at pi over 4. They've identified that. So let's look again. There's negative square root of 2 over 2 in the bottom, but there's another place right there where the y value is the square root of 2 over 2. So the other place is 3 pi over 4. Okay, that's the first one, 3 pi over 4. If n is any integer, all solutions of this are given by pi over 4 plus 2n times pi. And the first one's sure. I'm looking. Given by pi over 4 plus 2n pi, and x equals 3/4 pi plus 2n pi. Now let me explain why that is. If you start at pi over 4 and you go all the way around this circle and you come right back and you're at pi over 4 plus a whole trip around the circle is 8 pi over 4, because it'd be 2 pi. Then that's what they're saying. They're saying, how can you tell me, and if you kept going and going and going, 8 pi over 4 plus 1 would be 9 pi over 4. And if you went another 8 pi, you'd be at 17 pi over 4. If you went another 8 pi, you'd be at, I'm losing count, 25 pi over 4. That's what that means. Or you could start at 3 pi over 4 and make a whole trip around the circle, which would be adding another 8 pi over 4 or adding another 2 pi. That'd be 11 pi over 4. They're wanting to know how much do you have to add to get back to where it is. So if you start here, you have to add, you start at pi over 4, you need to go around the circle 2n times pi times, 2 pi times. That means one entire trip. Or if you start at 3 pi over 4, you need to go a whole trip. Sometimes you're not going to have to go a whole trip. Sometimes they're going to give you these kind of problems and you're only going to have to go half a trip. Okay? That'd just be pi. I know that kind of different, but that's what they're talking about there. So that is that. Okay, the next one says, find the solutions for tangent is negative square root of 3. Well, that's when y over x have different signs. Okay, y is positive and x is negative, or vice versa. So it's going to happen in quadrant 2 or in quadrant 4. And it's where the answer is going to be the square root of 3. So in quadrant 2, there's one opportunity right there, 2 pi over 3, where the tangent's going to be negative square root of 3. And then also down here at 5 pi over 3. So it's going to happen at, oh, they're going backwards. If you're talking about 5 pi over 3 and you're going backwards, then you're going to have to back up 1/3 pi, negative pi over 3. So they're wanting to tell you that you're going 0 to 5 x equals minus 4x equals 2 pi over 3. I read that wrong. They want you to say 2 pi over 3. If it is an integer, all solutions are given by. How far do you have to go around to get there? You have to go around. So this one is 5. 2 pi over 3 plus, you only have to go halfway around the circle to get from 2 pi over 3 to 5 pi over 3. There's just one trip. You don't have to go all the way around. Okay? Determine whether the following statement is true or false. If 3x equals pi over 4 plus n pi for any integer n, then x is equal to pi over 12 plus n pi. And the answer is B. The statement is false, because while pi over 12 is 1/3 of pi over 4, the n times pi term would need to be divided by 3 as well. Okay, and they didn't do that. That's just simple algebra. They didn't divide everything by 3. They only divided that part by 3. So this answer is going to be B. It's false. The next one, I think we're on number 4. Determine whether the following statement is true or false. If cosine of x over 3 is 1/2, then x over 3 equals pi over 3 plus 2n pi. That means that occurs at pi over 3, and every time you stop at pi over 3, if you're going round and round and round and round. Or x over 3 equals 5 pi over 3 plus however many trips around. Is it true or false? And the answer is C. It's true. Statement's true because the cosine of pi over 3 is equal to the cosine of 5 pi over 3, and it's 1/2. Because at both these locations on the unit circle, x is equal to 1/2. And because if you kept going 2 pi, one whole trip around, you'd land right back on that same spot where the x value would also be pi over 3. Okay? Macy, do you have specific ones, or have I kind of got you started on that? I don't know how our time's run.
On the 2 pi,
Why couldn't all of them be 2 pi? Because then if you go all the way around,
They want you, you're right. If you go all the way around, you're right back where you started. But there's a place between, like on the tangent one, you don't have to go that far. If you go all the way around, you're right back where you started. But you don't have to go that far to find the next time that it equals that. Okay, and usually when it's tangent, it's going to be 1 n pi, and the sine and the cosine are the ones that are going to be the 2 n pi. Okay, that works. You know, I'm not going to say 100% of the time, but most of the time, because they want you to tell them what's the smallest distance you can go and land back on a value like this. And you can't go those little piece values up here because it won't work on this side. All right. Another question? I'm not sure of our time.
It says less than a minute.
Less than a minute. Okay. I'm going to stop it.